Alright, Math 1, Unit 6 test review. So we're dealing with Pythagorean Theorem, distance, parallel, and perpendicular, and using those concepts to prove things about shapes. So, first thing, it says find the missing side of each triangle, round your answers to the nearest tenth if necessary. So here we've got right triangles, so we're going to use the Pythagorean Theorem. Okay, remember the Pythagorean Theorem is a squared plus b squared equals c squared. And what that means is when we look at a right triangle, that side opposite the right angle, that's our hypotenuse. Okay, that one's designated by the letter C. Okay, notice it's all by itself on the equal sign. The other ones, A and B, are the legs. They're on the other parts. Okay, and they're on the same side and they're squared and added together. So the length of this squared plus the length of this one squared equals the length of that one squared. So if we look at 1, 2, and 3, our variable is the hypotenuse. But if we look at 4, notice that 15 would be the hypotenuse. So you've got to be careful to make sure that you don't do 1, 2, 3 the same way you do 4. So 1 and 2 and 3, we just go, we've got our two legs, A and B. So I go 6 squared plus 8 squared equals x squared. 6 squared is 36. 8 squared is 64 equals x squared. 36 plus 64 is 100. So we take the square root of that. If you need to, you type it into your calculator, but the square root of 100 gives us 10. So our answer here is 10. Alright, number 2. So A and B, doesn't matter which one is A or which one is B, as long as you have the correct C. So I go 12 squared plus 9 squared equals x squared. 12 squared is 144. 9 squared is 81 equals x squared. 144 and 81 give us 225. Take the square root of that, and the square root of 225, you type it in the calculator, if you don't know, is 15. So that one equals 15. Now we look at 3, so A and B. So 5 squared plus 12 squared equals x squared. So we get 25 plus 144 equals x squared. 25 plus 144 is 169. Take the square root of that, and we get 13 for x. Okay. Then that last one, okay, notice this would be A and B, and that would be C. So we'd end up with 9 squared plus x squared equals 15 squared. See the difference there? So 9 squared is 81, plus x squared equals 225. Subtract 81. We get x squared equals 144. Take the square root, and x equals 12. Okay, now 5 and 6, they want you to state if each triangle is a right triangle. So the way you do that is you test the Pythagorean theorem. So I take our biggest number, we'll pretend that's our hypotenuse, we'll go 13 squared, equal to 9 squared plus 12 squared. And we want to see, are they equal? So 13 is 169, 9 is 81, 12 is 144, 81 plus 144 is 225. So is 169 equal to 225? It's not. So no, that's not a right triangle. Okay. Now, if we look at 16, okay, it's kind of similar, isn't it? We've got 9 and 12 here. So 9 and 12. And then 15 would go right here. Well, 15 squared is 225. Okay. So we should be able to see that actually this one's going to work, isn't it? Okay, and we saw it here in this triangle, right? So we'd go 15 squared equals 9 squared plus 12 squared. 12 is 144, 9 is 81, 15 is 225. 81 plus 144 is 225, they're the same. So number 6 would, yes, be a right triangle. Okay, now we want to find the distance of each pair of points. Now, if we look at 7 and 8, we have a vertical and a horizontal line. we like having vertical and horizontal lines as opposed to slanted ones, because then we just count. So from one point to the other, we went a distance of 2, so the distance is 2. Number 8, from point to other point, we go a distance of 3, so my distance is 3. Okay, so those ones you can just count. You don't need to use the distance formula or the Pythagorean theorem. Now on 9 and 10, you can either use the Pythagorean theorem like we did up here, or the distance formula, which is derived from the Pythagorean theorem. So what I like to do, especially when it's graphed, is I make a triangle. Okay, the slanted part would be the hypotenuse. Then I count. I went 2 to the right, then 1, 2, 3, 4, 5, 6, 7 up. So that's my A and my B. So I go 2 squared plus 7 squared equals C squared. 2 squared is 4. 7 squared is 49 equals C squared. 4 plus 49 is 53. Take the square root of that. So I could leave the answer as a square root of 53. However, since I can access a calculator, I can just as easily get the square root of 53 as a decimal, and we get about, C equals about 7.28. Okay, now 10, let's do this one with the distance formula. The distance formula is the square root of one of the y values minus the other y value. Usually we go y sub 2 and y sub 1 squared, plus that same x value minus the other x value squared. So that x and that y stand for points. Just two different points. That's what the sub 1 and sub 2 mean. So I find those points, so that would be 0, 4. This one would be 2, negative 2. And then we plug it into the formula. So I go the square root of a y value 4 minus another y value negative 2 squared plus an x value 0 minus another x value 2 squared. 4 minus a negative 2 is like plus. 4 plus 2 is 6. So we get 6 squared plus 0 minus 2 is negative 2, so we get negative 2 squared. 6 squared is 36. Negative 2 squared is positive 4. These are all under radicals. So we'd get the square root of 40, which, when we type it into a calculator, gives us about 6.32 for our answer. So there's two different ways you could do those. Okay, now if we look at 11 and 12 here, now we're just given points. Once again, we can use the Pythagorean theorem to figure it out, or the distance formula. So if we do 11, the distance formula, we just pick a y value minus the other y value squared plus. Now notice that I put the points that belong the same are in the same position. So 6 minus 4 squared. Okay, so negative 4 and 6 were this first. Positive 4 and negative 7 were the second one. They're in the second, they're in the first position. So that's plus. Negative 4 plus 7 is 3 squared. 6 minus 4 is 2 squared. 3 squared is 9. 2 squared is 4. 9 plus 4 is 13. And we'd get the square root of 13 for our answer, which is about 3.6. Okay? Now you could also do using the Pythagorean theorem. Okay? So the idea was that we made a triangle. So you could grab a piece of a graph, plot the 2 points, and then make a triangle if you really wanted to. Okay? Or what you could do is like this. Okay, because this triangle was the difference in the x value and this was the difference in the y value, we would just go, I would go negative 1 minus negative 5. That would give me a positive 4. Then I'd go 2 and 5, so 2 minus 5 give me a negative 3. That's like my A and my B, so I'd go 4 squared plus negative 3 squared equals C squared. So I'd get 16 plus 9 equals C squared. 16 plus 9 is 25. Take the square root of that. Square root of 25 is 5, and I get my distance as 5. So that's another way that you could do it. Okay, either way works. Now, for 13 and 14 and 15 and 16, we need to remember one thing, that parallel lines have the same slope. We also need to remember the slope-intercept form is y equals mx plus b. So the number with the x is our slope. Okay, so if we look at 14, a slope of a line parallel to that is going to be negative 4/5 slope. Same thing, because they're parallel. 16, they're parallel, so it's going to be 5/3. 15, negative 2, so it's going to be parallel to a slope with a negative 2. Any slope that's parallel has the slope of negative 2. Now number 13 is just y equals negative 2. Got to remember, when you have just y equals a number, okay, you've got a horizontal line. Y equals negative 2. The slope of a horizontal line is always 0, so that would be 0. Now, if instead it was actually x equals a number, then we'd have a vertical line. Okay, and a vertical line doesn't have a slope of 0. It's actually called undefined because it would divide by 0. Okay, so there's our parallel lines. Now for 17 through 20, we have perpendicular lines, and the thing to remember about them is that they are opposite reciprocals. So whatever the first one is, if it's like a over b, the reciprocal would be b over a. If it's positive, the opposite would be negative. If it was negative, the opposite would be positive. Okay, so number 17, 2 is their slope. So that's like 2 over 1. So the reciprocal would be 1 over 2. It's positive, so it would be negative. So negative 1/2 for a perpendicular slope. 18 is 3 over 4, so the opposite is 4 over 3. Actually, the reciprocal is 4 over 3. The opposite, it was positive, would be negative. Okay. On number 19, it's 3 over 2, so that would be 2/3. It was positive, our opposite would be negative. Now let's just pretend 20 was negative 3/4. So if that were the case, it would be a positive 4/3, because the opposite would be positive. But in this case, it would actually be negative again. Okay? Now, if we look at the next ones, these are the difficult ones, okay? So we need to write an equation in the slope-intercept form. So we want it to look like this. But numbers for m and b. Now, m is our slope, so we're going to use this information to find what our slope would be. Then, to figure out the y-intercept, which is b, we use these points plus this nifty little equation called the point-slope equation, which has a point as well as a slope involved. Okay? And the y sub 1 and x sub 1 stand for the y and x in that point. So let's see how we do this. So if we look at 21, the slope of this line is 3/4. Ours is parallel. My slope is 3/4. Now to figure out what our b is, okay, and to essentially get our equation as we simplify, we're going to say y minus y1, which would be negative 2, equals our slope, 3 over 4, times x minus our x1, which is 4. Then we're going to simplify this. Okay, it's like plus, so y plus 2 equals 3/4 times x would just be 3/4 x. 3/4 times negative 4. If we made negative 4 a fraction, 3 times negative 4 is negative 12. 4 times 1 is 4. Negative 12 over 4 gives us a negative 3. Another way to think about it is that the 4 on top and on bottom cancel out. Negative stays with it. So we end up with a negative 3. We subtract 2 from both sides. We end up with y equals 3/4 x minus 5. There's our equation that is parallel to this one that goes through that point. Okay? That's how we do those ones. Let's take a look at number 22. So, parallel to that, so a slope of 1. So I'd go y minus my y value, negative 1, equals 1, my slope, times x minus my x value, would be y plus 1 equals, if we multiply that it won't change anything, so x plus 5, subtract 1, we get y equals x minus 1. And there's our equation for 22. Now for 23 and 24 we have to do one extra step. Their slope is 2/5, ours is perpendicular, so we do the opposite, 5 over 2, and the reciprocal, so positive, we make negative 5 over 2 for our slope. So I go y minus a y value, negative 4, equals our slope, negative 5/2, times x minus the x value. Okay, negative 5/2 times x is negative 5/2 x. Negative 5 times negative 2, negative 5/2 I mean, times negative 2. See, 2 on top and bottom, negative and negative, positive 5 over 1, which is just a positive 5. And why did I write it like that? Negative 5/2 x equals, that's like plus, so y plus 4. Subtract 4 from both sides, and we get y equals negative 5/2 x plus 1. And there's our equation that is perpendicular to this line and passes through that point. Okay, so 24, same idea. So their slope is negative 1/2. Reciprocal is 2 over 1. Opposite is negative to positive, so positive 2. So I go y minus a y value, 0, equals 2, our slope, times x minus the x value. So y minus 0 is just y. 2 times x is 2x. That's like plus 2 times positive 1, positive 2. And there's our answer. Okay, and that's how you find those points like that. Alright, now let's take a look at some of these ones. So number 1, what is the approximate perimeter of a triangle ABC with vertices negative 2, 1, 0, 3, and 1, negative 1? So it looks something like this. So the idea here is perimeter, so we need to find the distance of all 3 of these pieces and then add them all together. Okay, now once again, 2 ways we can do it. We can use the distance formula each time, or we can use the Pythagorean theorem. So if we're using the distance formula, I'd find a and b first. Okay, so I'd go the square root of x value 1 minus x value 3 squared plus, did I say y or x? Can't remember. The other one, negative 2 minus 0 squared. So negative 2 minus 0 is negative 2 squared. 1 minus 3 is negative 2 squared. So we'd get 4 plus 4, so we'd get the square root of 8. Which that's about 2.83. So this side would be 2.83. Then we do the next one, b and c. So I'd go the square root of 3 minus negative 1 squared, that's these two, then plus 0 minus 1 squared. So negative 1 squared, which is 1, would be plus 4 squared, which is 16. 16 plus 1 would give us 17. So the square root of 17, which would give us about 4.12. Okay, then the last one, a and c, we would go square root of y value 1 minus y value negative 1 squared plus x value negative 2 minus x value 1 squared. So we get negative 3 squared plus 2 squared. 2 squared is 4, negative 3 squared is positive 9, so we get the square root of 13, which is about 3.6. So we'd have 3.6, so we add these all together. So 2.83 plus 4.12 plus 3.6, which all together gives us about 10.55, which if we round up to tenths would be B, 10.6. Alright, number 2, same idea. We've got these vertices, so we graph them and we find the perimeter. So it would look like this. Now the nice thing about here is notice B and C have the same x value. Okay, so that's vertical. And A and C have the same y value. So this is a right triangle. So I can just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that side length is 12. Here, 1, 2, 3, 4, 5. So that side length is 5. Okay, then we just find this one. Using the Pythagorean Theorem, we can just go 12 squared plus 5 squared equals that one squared, so 144 plus 25. So 169 equals c squared. Take the square root of that. We get 13 for c. So we have 13. So 13 plus 12 is 25, plus 5 would give us 30. So our answer would be A. Okay, now number 3, we want a quadrilateral, but it's the same idea. So now we just have 4 sides to deal with. So it would look something like this. Okay. Now once again, we can use that distance formula to find things out. So from A to B, a y value of -1 minus a y value of 3 squared plus an x value of 1 minus an x value of 3 squared. So we get -4 squared plus -2 squared. So positive 16 plus positive 4. So we'd get 20. Take the square root of that, which gives us about 4.47. Then we do the next one, so B and C. So a y value of 3 minus a y value of 0 squared plus an x value of 3 minus an x value of 9. So I get 3 squared plus -6 squared, so 9 plus 36, which 9 plus 36 would give us 45. So the square root of 45, which is about 6.71. So 6.71 here. Then we do it again. So 0 minus -4 squared plus 9 minus 7 squared. So that's 2 squared plus positive 4 squared. So 16 plus 4 again, okay, which would give us square root of 20. So that's 4.47 as well, isn't it? Okay, then we do our last one, A and D. So square root of a y value, -4 minus a y value, -1 squared, plus an x value of 7 minus an x value of 1 squared. So we get 6 squared plus -4 plus 1 would be -3 squared, which would give us 9 plus 36, which is 45, so square root of 45, which we know is 6.71. So, if we look at this, looks like we have a rectangle, even though my drawing and my graph were bad. We would probably check to see if those were opposite reciprocals, and if so, that would tell us if it's a square, or a rectangle. Okay, which we could easily find that because we'd go up 4 and to the right 2. Here we'd go down 3, so -3, to the right 6. So it actually wouldn't be, well, let's see, 4 over 2 would be 2, -3 over 6 would be -1/2. -1/2 is opposite reciprocal of 2, so that would be a right angle, and all the rest would turn out to be the same. So that would actually be a rectangle. Opposite sides are equal, and that. But to find the perimeter, because that's really all we're doing, we'd go 4.4 plus 4.47 plus 6.71 and 6.71, and we'd get about 22.36, which be about C. Okay, now the number 4 here. Okay, we've got another quadrilateral, so I'm going to do it the Pythagorean Theorem way, so I'd count 1, I'd essentially make triangles, right? That side length would be 1, this side length we'd go down 5. So 5 squared plus 1 squared equals c squared, so 25 plus 1, so we get the 26. Take the square root of 26, and we get 5.1. Then we do another one, so we go up 1, 2, 3, 4, 5, and to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we go 5 squared plus 10 squared equals c squared, so 25 plus 100 equals c squared, so 125. So take the square root of that, and we get about 11.18. Then we do the next one, so we'd go to the left 1, 2, 3, 4, 5, then up 1, 2, 3, so it'd be 5 and 3. So we'd go 3 squared plus 5 squared equals c squared. So it'd be 9 plus 25, which would be 34. So we take the square root of 34, and we get about 5.83. And finally, the last one. So I'd go up here, I'd go up 1, 2, 3. Then we'd go to the right, 5, and 1, so 6. So 3 and 6. So we'd go 3 squared plus 6 squared. So 9 plus 36, which would give us 45. And I think we found the square root of 45 before, haven't we? Which would be about 6.71. So then we add all these up. So 5.1, 6.71, 11.18, and 5.83, and we get about a perimeter of 28.82, which 28.8 would be right there. Okay, now we take a look at this last one, so last one of those. Now, my drawing's not the best, but we should notice a few things. First, these two make a vertical line. So this would be 1, 2, 3, 4, 5, 6, side length of 6. Here we've got another vertical line. See, their x's that are the same, so we'd go 1, 2, 3, so that would be 3. Then we've got this horizontal, so we count 1, 2, 3, 4. So this would be 4. So 4 and 6 would make 10, and 3 would make 13. Now we just need to find this last side right here. Okay? So, if we use the Pythagorean Theorem, we'd go 1, 2, 3, 1, 2, 3, 4. So it would be 3 and 4. So I'd go 3 squared plus 4 squared, which would be 9 plus 16, which would be 25. So it all equal the slanted side squared. Take the square root, and we'd get 5 for c. So 13 plus 5 would give us 18 for our perimeter. So those horizontal and vertical lines make it a lot easier. And we end up with 18 right there. Okay, and that's perimeter. Now we need to deal with area. Okay, so with the area, for a rectangle and quadrilateral, it's just length times width. For triangles, it's 1/2 times the base times the height. And when you're dealing with a triangle, the height goes from one vertex at a perpendicular angle, so the base and the height. For rectangles and quadrilaterals, we just go length times width. Now in number 6, we know it's a rectangle, so we know we really only have to have 2 sides, because then we just have to multiply them. Okay? So, let's figure out the first side. So using the distance formula, let's do this long side. So 7 minus 10 squared plus negative 5 minus 4 squared. Negative 5 minus 4 is negative 9 squared, plus 7 minus 3 is 3 squared. So we get 9 plus 81, which is 90. So we take the square root of 90, and we get about 9.49. Okay. Then we do this other side. So we go square root of y value minus y value squared plus x value minus x value squared. So it's like plus negative 5 plus 3 is negative 2 squared. 7 minus 1 is 6 squared. 6 squared is 36. Negative 2 squared is 4. So we get 40. So the square root of 40, which is about 6.32. So since it's area, we just go 9.49 times 6.32, and we get about 59.97. Okay? So 59.97, we just round up to 60. Okay? So, now we've got a few more to take a look at here. So we've got 2 quadrilaterals, then some triangles, and then one more triangle problem. Okay? Now, I'm almost out of time on this video, so we're going to have to use a second video to finish this off. So I'll end right here, and we'll get going on our next video.